Welcome to Electrical Safety Training. In this course, we'll review the risks associated with high-voltage electrical work, the injuries these exposures can cause, and the steps workers can take to protect themselves on the job. After completing this course, you should be more aware of the risks of high-voltage electrical shock, how workers can protect themselves during high-voltage electrical work, and how serious these injuries can be. You should also understand why proper medical treatment must be provided quickly and effectively whenever a worker is injured by this type of hazard. In simple terms, damage from high-voltage electrical fields is caused mainly by heating and, to a lesser extent, by damage to cell membranes. Heat damage usually occurs instantly at the point of contact, while injury to deeper tissue can take several seconds to develop. Since most tissues in the body conduct electricity fairly well, once the outer layer of the skin is destroyed by heat, large electrical currents can pass through the body and cause damage to muscles and nerves. Electrical injuries aren't limited to burns and internal tissue damage. Arc blasts can also cause serious impact injuries such as falls, broken bones, and concussions. In addition, workers may experience non-physical effects like reduced attention, slower mental processing, memory issues, and post-traumatic stress. These effects can be just as life-changing as a major physical injury, and workers with electrical injuries may show a wide range of signs and symptoms. For exposures above 1,000 volts, electrical burn wounds have unique clinical characteristics. Below that level, cardiac fibrillation is often the main concern, while visible skin injury may be minor. Above 1,000 volts, however, the risk of severe wounds and even amputation increases. One of the biggest challenges is that tissue along the electrical path may look normal at first, and it can take 1 to 3 days before the true extent of the damage is recognized. As a result, even workers without obvious visible injuries may still suffer serious consequences. Electrical burns account for only a small percentage of all burn injuries, so specialized treatment knowledge has developed more slowly than for other types of burns. At this time, there is still no reliable way to estimate the full amount of tissue damage caused by heat that has already dissipated. That means tissue may appear healthy, even when serious injury exists underneath. Employees and employers need to understand that even without a visible burn, survivors may face long-term muscular pain, fatigue, poor balance and coordination, or even limb amputation. Although people often talk about entry and exit wounds, that's not really how alternating current works. Instead, one contact point usually has lower resistance than the other. In some cases, skin damage seen at the hospital may be very small, even though internal damage extends much farther. That's why workers exposed to 1,000 volts or more should be taken to a specialized burn center, or the 911 operator should be told clearly that this is a high-voltage shock requiring burn center evaluation. Treatment can be complicated by progressive tissue death and the difficulty of identifying which tissue is still viable. When doing electrical work, always ask what controls are in place and what procedures are required. High-voltage work should only be done by workers who are trained and authorized. Follow plant procedures for breakers, motor control centers, transformers, and other electrical equipment. Take the precautions that match the hazard class of the task, wear the PPE required for the voltage involved, and maintain current first aid, CPR, and AED training whenever an AED program is in place. Every effort should be made to work only on de-energized circuits and equipment. If energized work must be performed, CPR and AED trained personnel should be available, which means at least 2 workers should be present. As with other workplace hazards, electrical risk should be controlled first through engineering controls, then work practice controls, and finally PPE as the last line of defense. Worker placement, training, and written procedures remain critical parts of electrical safety. If a worker is exposed to 1,000 volts or more, initiate emergency response immediately. Be specific with the 911 operator that the injury involves contact with over 1,000 volts and that immediate evaluation by a burn center is needed. Electrical accidents can happen in many ways, including changing fuses under power, bridging terminals with a metal watch band, using a meter on the wrong setting, or creating arc burns during welding. If work involves parts energized above 600 volts, a second person should always be present to assist in case of shock. Selecting PPE for electrical work is challenging because both the hazards and the equipment continue to evolve. Electrical flame-resistant clothing is still advancing, and NFPA 70E continues to change as new information becomes available. Although many workers don't face the highest voltage exposures every day, occasional work in areas like switchyards may require a fresh evaluation of whether current PPE is adequate for switching, inspection, groundskeeping, and similar tasks. As PPE technology improves, the equipment considered appropriate this year may not be the same next year. All high-voltage areas, enclosures, boxes, and cabinets should be marked with proper signage in accordance with OSHA requirements. Equipment at 50 volts or greater should be isolated from people and labeled with a warning sign. Equipment at 600 volts or greater should be enclosed, insulated, secure, and clearly marked. High-voltage areas should be kept dry and weatherproof, and access should be limited to workers with the proper training. Where appropriate, multiple levels of restricted access should also be monitored. Workers who perform electrical service work should be familiar with the key regulations and standards that apply to their jobs. These include NFPA standards for electrical safety in the workplace and OSHA standards for electrical protective devices, lockout and tagout, electric power generation, transmission and distribution, and ANSI C2, which is the National Electrical Safety Code. The key to protecting all employees is making sure workers understand the equipment they use, the procedures they must follow, and the hazards they face. Worker awareness and a commitment to improving protection over time are essential for reducing risk. Every worker should remember that personal safety comes first. This training is built on information from OSHA and the Energy Recovery Council.